M1, M2 with M1 are horizontal in front of each other and pushing her against it. Hello everyone, my name is Jordan. I'm going to explain how to do the question we were asked about. So, as you can see, question mark asks us the block of masses M1, M2 with M1 horizontal in front of each other and pushing her against surface as a figure. This is the horizontal everywhere. So, as you can see, I've tried to write the formulas right here to explain. So, as you can see, so when according to Newton's second law, force is equal to mass of acceleration, and acceleration is inversely proportional to the mass and directly proportional to the force. And as you can see, our magnitude of acceleration will be the force over the summation, because we're treating M1 and M2 as the system, not as different parts. So that is literally a final magnitude of the acceleration of the system. So this is going to take M1 and M2 as a system, but not as two different bodies. So the acceleration is going to be is equal to force over M1 plus M2. So for the second question, determine the magnitude of the contact force between the blocks. So in between the blocks, according to the Newton's third law, for every action there is a reaction force that is equal to the action force. So as you can see, our force is equal to mass times acceleration. And because we have two bodies, right? Two bodies. So in between there is a force applied to body 2, and there is also a force that body 2 applies to body 1. They have to be the same. So how do you find that force? So that force is found by this formula. It's M1 M2 over M1 plus M2 times the summation of the forces. And I expanded the formula to show you where it all goes to. So the formula for summation of forces is equal to M1 plus M2 times acceleration. And once you
I'm screen recording it.
simplify, you get M2 times A. So that the force, this P, that the force that body 1 applies to body 2 is equal to M2 over M1 plus M2. So this P12 is actually in between the bodies. And according to the third law, it goes like this, and also it comes back like this between the two bodies. So the last question, is: imagine the force F is applied towards the left and the right hand block of mass magnitude F. In the same end as it was in the first. So they're literally telling us it's going the other direction. That's what they're saying. We were first going like this, but now we're going like this. So as we know, um, acceleration, and the acceleration does not depend on the direction of the force, because it's the magnitude. Acceleration does not care if we're moving south, west, east. The only thing it cares about is the force in the mass of the object. But get me right. The contact between the bodies is going to change. Why is it going to change? I do something right here. As you saw the formula back, the formula between the contact between the two bodies is literally M is gonna change to M1. Before it was M2 because
Buy me a
it
honey bun.
was the force of body
A
1
honey bun.
that is
2.1.
being
Is this
pressed 2. But now our body 1 is no longer M2, it is M1. And we know that M2 is less than M1. So it's gonna make this force between the two bodies. It's gonna make the force between. Let me show you. It's gonna make the difference between the two bodies greater, as you can see, because this is greater than because M1 is greater than M2. So as you can see, the force between the two bodies will increase, making the force between them higher than it was before. So it will change when you do it.
Yeah. I mean, I don't like, yeah, I don't want to. I know it's hard. No, I was not going to spend 1.5 years. So we're not two.
Jesus Christ.
I don't even know how I got 400 views.